In this section, we learn how to evaluate the limit of the function by using the limit property principle and the limit of rational function theorem. This theorem here saying if we have function f at a inside the domain of f, then to find the limit of the function f when x goes to a is the same thing as to evaluate the function at exactly a. This only works when a is inside the domain. If a is not inside the domain, then we have to do the actual work. So here the example, I will show you how to find a limit. Example A. I'm looking for the limit of this function here, where x goes to 2, meaning x goes very close to 2. Now you see this function here is a polynomial. The domain of the polynomial is all real numbers. So you see a is 2 is inside the domain of this function. So therefore to find the limit of this function, all we have to do is evaluate the function at a by using this theorem and the limits of property or principle. So we have 2 I evaluate the function at 2. So put 2 to the x minus plus 2 squared minus 7. So I have 16 minus 2 to the q is 8. 8 times 5 is 40 plus 4 because 2 squared is 4 minus 7, which is equal to minus 27. That's our limit. Part B, we want to find the limits of this rational function when x goes to 0. First, we will see if this value 0 here inside our domain or not. Now this is a radical function. We're allowed to have 0 in here and a positive number only. So if you observe this here, when you put 0 inside this function here, our radical becomes 0 minus 3 times 0 is 0 plus 2. So in other words, I 0 inside this domain. Because I can evaluate at 0, I got 2. So in other words, when x goes very close to 0, this function here goes very close to the square root of 2. Part B. Part B, I want to find the limit of this function x squared minus 9 over x plus 3. So first we have to see if this value a here, which is minus 3, is inside this domain or not. You see when you put minus 3 inside the x here, you have minus 3 plus 3, which is 0. In other words, I have 0 at the bottom and have minus 3 squared is 9 minus 9, which is 0 over 0. You see, minus 3 is not inside this domain because if x equal to minus 3, our domain here is explode or undefined because I have 0 in the bottom. We cannot divide by 0. Or if you put a minus 3 here, directly inside here, you have the case when 0 over 0, which means our function is indeterminate when x go exactly minus 3. So the better way to do is This form here we call indeterminate form. Okay? We don't know what 0 divided by 0 equal to, because we cannot divide by 0. And also because minus 3 here is not inside this domain. So when this happens, we have to do extra work by go inside our function and rewrite our function or massage our function to the recognizer. So I can rewrite this here as a limit of this numerator here can factor out x minus 3 times x plus 3 over x plus 3. This here cancel out, so I will have a limit of x minus 3 when x go to minus 3. Now we can evaluate this, because this minus 3 here now is inside this domain here, because minus 3, we can evaluate it. It's a linear equation. Linear equation or linear function has the domain of all real number. So minus 3 inside that domain, so therefore I can evaluate this limit by using the theorem, which is minus 3 and minus 3 equal to minus 6. Now same problem, but now I'm asking you to find a limit when x go to 2. You see, when x go to 2, this 2 here belong into our domain. So when x equal exactly 2, nothing happened to our domain. So therefore, to evaluate this here, to evaluate this limit, all we have to do is set it to the value 2 directly inside our function, which is 2 squared minus 9 over 2 plus 3 equal to minus 5, because 4 minus 9 is minus 5 over 5, I got minus 1. That's our limit. Last example. Now, if you're not sure if phi here belongs to this domain or not, this the domain of this function or not, the best way is try to substitute the phi inside here and see if you have 0 over 0 or not. So 5 minus phi is 0. I have 25 because x squared I put inside here. Minus 6 times phi is 30 plus phi. I have 0 over 25 minus 30 is minus 25 plus phi is 0. You see, when we substitute the value of phi inside here directly, I have 0 over 0, which means indeterminate form. That means we can't determine whether this is equal to 0 or undefined. We can't icky about this. Alright? So therefore, when this happens, all we have to do is go back here and try to rewrite our function by factor out. So I have x here, x there. The plus sign means I have two same sides. So I have 5 and 1. This here cancel out. I have 1 over x minus 1. In other words, our limit of this function here can rewrite as the limit of 1 over x minus 1 when x go to phi. So now we go since when x go to phi and phi belong inside this domain, so we can evaluate the limit directly by substitute the x by phi. So our answer is 1 over 4.